A robot that can do a backflip but falls over reaching for a coffee mug is useless. And right now, that's most humanoid robots. Here's the thing. Stand on one foot and close your eyes. Feel your ankle making those tiny corrections? Your arms drifting out for balance? That's dynamic balancing, and your brain does it without you even noticing. For robots, this is brutally hard. Walking isn't graceful forward motion. It's controlled falling. You tip forward, catch yourself with your foot, repeat. Now imagine doing that while getting shoved, while stepping on uneven ground, while carrying something heavy. Boston Dynamics has spent 4 decades cracking this problem. Their Atlas robot does parkour, backflips, recovers from aggressive pushes. It traces directly back to founder Mark Rybert's MIT Leg Lab work from the 1980s. 40 years of hand-tuned physics, deep understanding of forces and momentum. The results are spectacular. The problem? That engineering is expensive, requires world-class talent, and doesn't transfer easily to new robot designs. But here's where it gets interesting. A Chinese company called EngineAI just did something nobody expected. They claim the world's first humanoid front flip using pure neural network control. No hand-tuned physics, no scripted movements. A neural network directly commanding all 32 joints simultaneously, learning balance the way a child learns to walk. Through trial and error in simulation, then transferring to the real world. This is a fundamentally different bet. Boston Dynamics says, understand the physics deeply, engineer elegant solutions. EngineAI says, let the AI figure it out. Train it on millions of simulated falls until it develops intuition we can't even explain. The front flip is a flex, sure, but what it represents is a path to balance that doesn't require 40 years of institutional knowledge. So, who actually has the edge? I'd argue it's Unitree. They're playing a different game entirely. While Boston Dynamics builds the most impressive robots and EngineAI pushes neural network boundaries, Unitree focused on vertical integration. They make their own motors, their own reducers, their own controllers. The result? Price points 5 to 10 times below Western competitors. Their G1 humanoid is now used in over 30 academic whole-body control studies worldwide. They're essentially crowdsourcing locomotion breakthroughs. Every PhD student publishing research on Unitree hardware feeds discoveries back into their ecosystem. Cost structure plus research flywheel is a combination that's very hard to beat. Now, this is the part nobody talks about. Neural networks excel at agility but fail unpredictably. A robot that nails 99 backflips and catastrophically botches the 100th? Fine for YouTube demos. Completely unacceptable in a warehouse next to humans. Physics-based systems are predictable but rigid. Learned systems are adaptable but unreliable. Nobody has bridged this gap. Whoever figures out how to combine the adaptability of neural networks with the predictability of physics-based control will own the next decade of robotics. So why does this matter? This isn't about robots doing parkour tricks. It's about whether machines can operate safely in human spaces. Hospitals with cluttered hallways, homes with toys on the stairs. Get dynamic balancing right, and humanoid robots become real tools for elder care, manufacturing, disaster response. Get it wrong, and they remain expensive demos that can't be trusted around people. The future of useful robots comes down to one thing: the art of not falling down.